This is video number 4 for sections 6.4, 6.5, and 6.6, factoring polynomials with 4 terms. We've been covering our overall factoring strategy. Step 1, pull out the GCF. Step 2, count how many terms there are remaining because the method you choose will be based on the number of terms. We've covered 2 terms, we've covered 3 terms, and now in this video we'll cover the situation where you have 4 terms and you're trying to factor. Once again, there are 2 methods. I'll show them both to you. They work interchangeably. You could do them all using the first method, you could do them all using the second method. I just want you to have some options. The first method is called factor by grouping. You can see the example problem there. Step 1, pull out the GCF. If you examine this guy, I think you will find there's nothing to pull out. The first 2 guys don't have any numbers, and the back guy doesn't have an x, so I don't have anything in common to all 4 pieces. Factoring by grouping goes like this. Rewrite the problem, grouping the first 2 items together. When I say grouping, I mean put them in a set of parentheses. Then put a big plus. That plus is very, very important. And then group the back 2 together. I have not changed anything substantively in this problem. In front of each parentheses is basically just a positive 1, right? There's a 1 here, there's a plus positive 1 here. That's why that plus is so important. If you distributed the 1, you'd just get back to what we had a second ago. Why do this then? Well, because I've just created pairs of terms, and even though the whole thing didn't have a GCF, each pair does. Well, let's go ahead and factor each pair here separately by pulling out the GCF. If you look carefully at the first pair, I don't have any numbers, but I do have at least 2 x's in each term. It has to be the greatest thing I can pull out, that GCF. That leaves me with 1 last x from the x cubed. Now I took everybody. I took both x's from the second guy. There has to be something left though. What would I multiply times x squared to get back to x squared? Well, that would be a 1. The understood 1 that was there all along. From the second pair, remember when the lead coefficient is negative, you're to take that out along with your GCF. So I'm definitely going to be pulling out a negative. That'll change that sign from a positive to a minus here. And it looks like I also have a 4 that I can pull out. I don't have an x in this back guy, so that's as good as I can do. I'll open my parentheses. Negative 4 times blank is negative 4x, that would be an x. Negative 4 times blank is negative 4, that would be a positive 1. All right, now take a look at what we have. We've now rewritten this thing so that there are essentially 2 sort of giant messy terms, this guy here and this guy here. And do you see what's great about those 2 terms? They now share a GCF, a common factor, namely the x plus 1. It's sitting there in both. And so what I'll do is I will pull that GCF out to the very front. Let me write it in sort of an exaggerated way. And then I'll open a parentheses to fill in what's left from each of these messy looking terms after I pull out the x plus 1. Well, the only thing left from this guy would be the x squared. And the only thing left from this other guy would be the minus 4. Well, what we've done is, notice we've just come up with a multiplication problem. X plus 1 times x squared minus 4. If you were to FOIL this out, you can check it. If you were to FOIL this out, you will come up with our original polynomial. That's the method of factoring by grouping. Now, this problem turned out to be a little bit tricky though, because do you see that we're not done? One of these 2 binomials that we just came up with keeps going. It factors out a little further. Now remember, binomials, there's only 3 categories: difference of squares, sum of cubes, difference of cubes. Look at this back item here. I see a minus sign in the middle, and then I'm noticing, wait a minute, X squared is a perfect square, right? Because x times x is x squared. And 4 is a perfect square because 2 times 2 is 4. This guy is a difference of squares, so I need to keep going. The x plus 1, I can't do anything further with that, but the x squared minus 4 further factors into an a plus b, a minus b situation. Here is the final answer to the problem. I always factor as far as I possibly can. One thing I always remember about factoring by grouping, if you've done it correctly, these two parentheses are going to match. That's really the key to the whole process. If they don't match, it either means that you've made a mistake somewhere or that the polynomial simply won't factor, that it's prime. Well, let's go down to our second method. Method number 2 is using a box. You'll notice it doesn't say the X box method. That's because you don't need the X. This is a little bit simpler, honestly, than the X box method. You can factor these 4-term guys just using the box. The reason you don't need the X is there are 4 terms. I'm not going to have to wonder what to fill in my 4 boxes. It's all ready for me to go. Now let's do the steps in the right order. Step 1, of course, is try to pull out a GCF. I'm looking, let's see, this third guy doesn't have any numbers, so I'm stuck there. This first guy doesn't have any Y's, so that's not going to work. What about X's? Wait a minute, look, they each have at least one X. The back guy only has one, but they all at least have one, so I'm going to have to start by pulling out that GCF. You can always mentally check, right, with the distributive property to make sure that you've done this part correctly. All right, so I've pulled out the GCF. Step 2, count up how many terms there are left. 1, 2, 3, 4. Of course, it's the same number of terms that I started with. 4 terms, I could do this with factor by grouping, and you could certainly try that later, but let me show you how this is going to work with the box. You're going to take those 4 pieces, again, you have no question what the 4 pieces are, and you're going to immediately fill them into the 4 boxes. Just go in order, starting at the upper left, reading across the first row, and then moving down across the second row. If I had had any negative signs, I certainly would have included those with my terms. That's all very, very important. Well, to finish this off, I just do exactly the same thing that we did in the Xbox method. I just need the outer edges. The outer edges is the original FOIL problem that created these 4 pieces. So remember how to start. Start by pulling out the GCF of the top row, just the top row. So what have I got in common there? 2x squared and 6x. Well, I can see a 2, and it looks like a single x. That's really the only GCF you need to pull out. From this moment on, you're just reversing the multiplication process. Think about how you use these boxes to multiply. For example, whatever goes up here, this times 2x has to make 2x squared. What would that be? That would just be a single x. Or how about right here? This spot times the x has to make the xy. Well, that means it must be a y. And lastly, this spot times the y has to make 3y. I need a 3. The pieces you have along the outer edge are the pieces of the FOIL problem. This time everybody's positive, so there's just going to be pluses in between there. When you go to write your final answer, don't forget, it's very easy in these problems because you did it so long ago. Don't forget to start with your GCF that you pulled out. That is part of the answer. And then put your other factors. I had an x plus 3, and I had a 2x plus y. Whatever you're writing down as your final answer should be a giant multiplication problem. If you were to multiply this all out, you would get back to your original polynomial. And you can try that later if you like. Unless the polynomial is prime, the box method will work every time for factoring 4-term polynomials. If you like the box, you might want to try that first example that we did by grouping using the box to make sure you can get it all to work out for yourself.